to detect Parkinson's disease using machine learning. So, Parkinson's disease is a disease which is difficult to diagnose. Usually, there are many misdiagnoses where people are told that they are suffering from Parkinson's, but they are actually not. And the reason why misdiagnosis is so so dangerous is because you people start taking the wrong cure, and what that causes is it worsens your actual the actual ailment you're suffering from gets worse as you're trying to deal with a problem which isn't even there. And so misdiagnosis is a very big problem, especially in diseases like Parkinson, where there is no clear test which you can refer to be sure of whether you have Parkinson's or not. Now, the requirements I have already said. So, presently, the way Parkinson's disease is detected is you go to a neurologist who examines you. Then, based on abnormalities that he finds, you have your imaging, drug reaction test, dopamine transporter test, and all that. But it clearly says here the result of the dopamine or the L-DOPA test, which is the drug reaction test, is not clear, right? And these tests may have to be performed several times to be sure whether to get at least a decent surety on the fact that you have Parkinson's. So this process, the current process, is very inefficient. It requires a lot of time, too many tests. Tests are cost money, so cost inefficient, time inefficient, and still the accuracy is not high enough, good enough. So the present method of doing this is not optimum. Now, the challenges that we face when trying to, the current challenges are late realization of disease being present. Parkinson's is not an easily identifiable disease. It's similar to Alzheimer's, and there are other diseases which are also very similar. The process is not fast. As I said, it takes multiple tests and visits to the doctor, right? High chance of misdiagnosis, L-DOPA test is unclear. So there are many challenges which need to be addressed here. And to deal with these challenges, the solutions that we have found are, there are also of course programming challenges, right? Because so the way we are going to create this machine learning model is by using MinMaxScaler and Xgboost. Now, the reason we are using these two technologies is written here, and mainly Xgboost is a very new algorithm created like 4 years back, so it's very new, and people have been using Xgboost a lot recently. It has shot to fame. People have been winning Kaggle competitions using Xgboost. So this is the methodology or the method we will be using to to detect the disease. Okay, so main reason why our accuracy score, of course, expected around 93 to 95%. Xgboost can give you that much, right? Because yes, and then you can there are further parameters that you can provide to improve your accuracy above 93 to 95%. Like you could put in L1 and L2 regularization, cross validation, entropy error. There are many methods that you can use to improve your accuracy, but for now we will be using the basic version where you can expect an accuracy of 93 to 95%. Also, Xgboost is of course very fast at being trained. We'll get to that. So first thing we will do is of course scale the data, which is necessary because what happens is usually there are some values which are larger than others, right? Like, there are, all values are not equal, so there are some values which are larger, and the larger values, because of their being large, are able to affect the predictions more, and that's not necessarily how we always want it to be, because despite one variable being larger doesn't mean that it's the most important variable out there. So currently there are the solution to this is scaling. So what scaling simply does is takes every feature, every variable you have, every value within the variables, and turns them all to values between 0 and 1. Simply converts it to percentage, or like that. Not exactly percentage, but similar. So there are three main types of scalars used for scaling, and these are standard scalar, MinMaxScaler, and robust scalar. They all have their methods and advantages, but we are using MinMaxScaler. XGBoost is a very fast algorithm. It takes it's like really fast. It takes like only around 20 seconds to run something which can take 2000 seconds with gradient boosting. So it's quite fast, while also getting a slightly higher accuracy. So now, of course, we will start with data acquisition, because we will require a good amount of data so that our machine learning model or XGBoost model can identify which factors are, influencing the classification, where it is right, where it is wrong. So of course we are using this Parkinson's data that we have taken. I will give a link for that. Features. Okay, so here we are separating the features and labels, and this is very important because if there is any problem here, you might end up leaking your labels into the features. Same for train test, you might end up uh, spilling your testing data into the training data, and what will happen is your model will perform very well, like way too good, 98%, but the moment it goes and gets new data apart from the train and test, you might end up having a 70% accuracy. So that's why it's very necessary that the train and test data don't spill into each other. The reason we say scalar equals min-max scalar minus 1 comma 1 is because it can also scale the values to negative, provided that you have a feature which has negative values in it. So the model creation, we are simply just loading our model, fitting it, getting an accuracy score. Now after getting the accuracy score, obviously you will get 93 to 95%, so your model is now really good at detecting Parkinson's disease. um, so in summary, the problems that we had were almost all dealt with. Like the process is not fast enough was solved by XGBoost, right? Higher chance of misdiagnosis was solved, your inaccuracy was solved, right? So overall, in summary, this method was quite useful and also did not require too much computational power. It was fast, easy, and worked well overall. But there are, of course, obviously some improvements, since because even despite your 95, 90 95% accuracy, considering the amount of people who go through Parkinson's every year, it's way too big a value that you're leaving out. So there are methods that you can use to achieve even better accuracy. Obviously we will cover that in the future.